Okay, so what we would like to discuss today is we want to talk about the weather. And we don't have anything else to talk about, discuss the weather, right? But we want you to expand your ideas of weather, okay? We want to talk about weather across the solar system. Okay, so we have an exercise to start with the engagement of it. Now, do you think your students have thought about, first of all, do they think about weather normally, right? You check it on your phone, on your iPad all the time, right? But have they thought about weather elsewhere in the solar system? Okay? And matter of fact, what we find is most people haven't considered the idea of weather elsewhere in the solar system. So we need to get them thinking in that mindset before we can then sort of prime the pump to get them engaged, all right? So we're going to start by looking. What can you tell by just looking, okay? First of all, what's this? Anybody who knows it, you can just say out. All right, that's Jupiter, okay? What do we know about Jupiter and possibly in terms of weather, which we just discussed in the wonders of the solar system? So this should be easy.
What's that?
What?
Oh, yeah.
The great red spot is a storm. Storms are part of weather, right? Okay, all right. What else about Jupiter? Just looking. You don't have to actually, this is not asking you for knowledge that you don't have. It's what can you see with your eyes? What will your kids see? All right, maybe I should just phrase it that way. What do you think your kids would say about this picture? Stripes. Okay, I heard stripes. What else? All clouds and such, okay? Clouds, stripes, storms, all right? We're going to put Jupiter back here. You guys are going to hold on to Jupiter. All right? Give me something else. That's another one, okay? All right? What do we think this is? It's an object in the solar system. All right, speak up loud. Huh? A moon, okay? It could be a moon. All right, what do we see on it? All right, let's ask over here. What do you see on it? What do those look like? Is that surface? Is that clouds? Is that what? All right, clouds or something, all right? Matter of fact, it is lots of clouds. All right, and do you see the stripes that we saw on Jupiter? Okay. Do we see the colors we see on Jupiter? All right. Anybody have a guess as to what this is? Venus. It's Venus. Yes. All right. This is Venus. Venus has a very thick cloud cover on it. Okay. And you can see the sort of chevron shape. I'll talk about that a little bit today as well. All right. Do you know what size? How big is Venus? Anybody know? Just that's a factoid thing.
Oh, it's the size of Earth, isn't it?
It's about the same size as Earth. Okay. All right, since you identified it as Venus, we'll put Venus over here. All right, what else we got?
Since they brought up the moon?
All right, we'll bring it up. Okay, how about this? What do you think this is? Huh? Speak up loudly. Come on, you guys are wimps this morning, aren't you? Probably our moon. It looks like our moon. You're right, it does look like our moon. It's not our moon. Okay? All right, what do you think? Any other guess? Mercury. Who said Mercury? Okay, yes, it is Mercury, okay? Mercury and the moon look a lot alike, which is why we do them together. All right? You see, you see a hard surface and you see lots of what? Craters on them, okay? Lots of circles and craters. Both of them have them. What the moon has that Mercury doesn't have is it has these smooth patches, okay? Basically what those are basaltic lava plains in terms of crater impacts that lava welled up from the impacts and filled in to fill in some of the craters. You can see that they're circular in size, and so they've got lots of things. All right, so Mercury's going to go over here, all right, and we'll put the moon over here. All right. Anybody recognize this object here? Neptune. Why? It's got that beautiful blue color, right? Okay. What else does Neptune have? Do you know what that is right there? It's a storm, okay? It's big and it's dark. So what do astronomers call it? We call it the Great Dark Spot. We have a great red spot over here. We have a great dark spot over here. All right? Really we're not terribly inventive sometimes. All right? What type of planet is this? People call it a gas giant. I've actually stopped using the word gas. It's a giant planet because it does have an atmosphere, but by volume it might be more liquid than it is gas, which is kind of interesting about that, okay? Jovian is the Jupiter-like planets, yes, in terms of the giant planets and such. All right, so we've got Neptune. We've got a storm here on Neptune. Do we see any surface on Neptune? There are some rings, but actually these are clouds here. Okay, that's stretched out clouds, so that's not that isn't actually surface. All right, that's cool. All right, so these are it's like Jupiter. It's lots of atmosphere. All right, Neptune's going to go over here. What do we got next?
You want to?
Whatever you like. You tell me. All right. How about this one? Anybody recognize this? Mars. Okay. What do we see on Mars? All right. Oh, who said that? I did. Oh, there you are. Okay. My hearing is off. Okay. We have an ice cap up on the top of Mars. Did you know that Mars had polar caps? Okay. Mars has polar caps. What else? Have people over here. What else do you see on it?
Craters.
Craters, yes, definitely. Mars has lots and lots of craters. All right. It also has it has like a scar across here. We'll talk about that a little bit later today. Okay. Do you see lots of clouds on Mars? No. Okay, but you see a hard surface on Mars. Okay. Important things to try and recognize. Mars is going to go over here. Okay. Ooh, this one's not a fun one. Who said that? Oh, do we get the teacher? This is Uranus, okay? Uranus is pretty darn boring, all right? Now, why is it boring? Well, because invisible light, there's nothing much to see, okay? You get this wonderful, beautiful light blue, and that's about it, right? Okay? What type of planet is it? Is it a rocky planet or is it a giant planet? It's a giant planet. So what are we looking at here? Are we looking at surface or are we looking at clouds? Looking at clouds, all right? In terms of factoids, there's one factoid about Uranus that is fun to know, but not much else. And that's that Uranus is over on its side, okay? That most of the planets are pretty much upright, especially like Jupiter is upright and spin. And John, will you play the sun? Okay. As they orbit the sun, they're pretty much upright, okay? And they're spinning like this, okay? Uranus is tipped over 97 degrees, so it's rolling like this. As it orbits the sun, it's rolling like this, okay? That's the factoid that I can't think of any other factoids that people remember about Uranus. Okay.
Just everybody has trouble with the name.
Yes.
This might be a dumb question.
Sure.
How did they discover that it's rotating on that alternate axis? What
Using
kind of
Doppler shift. Okay.
Okay.
You would measure the Doppler shift on different sides of the planet and be able to see. If also when you look in infrared, you can actually see some features and you can see them rotate. Okay. Yeah. Just looking at this, it's like, okay, how can you tell that it's even spinning, right? Yes.
Was the planet struck?
Huh?
Was the planet?
We have no idea how it got tilted over, but we assume that there was some sort of impact early in the solar system that caused it to rotate over on its side. Okay? It actually is a really interesting dynamical problem, how you would get something this large to tilt over. All right? Okay, so who doesn't have one? You guys don't have one. You guys get Uranus. Okay, good. All right, now we're going to have a fun one. What is this one? Any guesses? You don't have to know the answer. You're allowed to guess here. This is the whole idea. Huh?
It's Epcot Center.
Epcot Center, okay. Last week they called it, who said that?
Disco ball.
Disco ball, yes. All right, this is the third time in a row that we've done this and we've gotten the answer, disco ball. All right, so this disco ball is basically pixelated because you can't see the details of it. I'm sorry, I'm just not going to try and yell over top of a leaf blower.
It's clean now.
Okay. So we paused to clean our steps. All right. So this disco ball is very small and very far away, and so what we're actually seeing is pixelation. And this isn't really, that's what it is. It's Pluto. This isn't really a picture of Pluto. It's a map of Pluto based upon some pictures of Pluto. Okay, for being very small and very far away. All right. What do you think you're looking at? Are you looking at clouds or are you looking at surface?
Probably clouds.
Probably clouds. What do you think? Surface. Okay, if Pluto's really, really small, it's not going to hold much of an atmosphere, okay? All right, so it's this is going to be surface. It's going to be an icy surface. We believe Pluto has a very, very thin atmosphere, although some might call it a coma, because if it comes toward the sun and creates an atmosphere and goes out and that atmosphere pulls out, that's sort of what a comet does, all right, in terms of creating an atmosphere and going away. But if you call that a coma, the folks who actually love Pluto really get mad at you, okay? So they like to call it an atmosphere, a tenuous atmosphere, a thin atmosphere, a trace atmosphere, something like that, okay? All right, so who doesn't have one over here? We're gonna give this over here. You guys get Pluto over on this table. All right. Another small pixelated object here, all right? What do we think about this one? Okay, another small pixelated object. All right, because you can see that it's pixelated, it's obviously going to be small, but this one isn't quite so far away. All right, anybody have a guess? Who said you said an asteroid? Somebody said an asteroid? Okay, you said an asteroid. Yes, it is an asteroid. It's the largest asteroid series. All right. Again, we're trying to look at the diversity of objects in the solar system. We're considering not just the sun and the 8 planets. We're also considering Pluto and the asteroid. This is the largest asteroid series, which we have some really cool images that we'll show you later on this afternoon because we got it. What do we think we're seeing here? Are we seeing surface? Are we seeing clouds? What are asteroids made of? Rock, right? So we think we're seeing a rocky surface. Okay? Asteroid going to go over here to you guys. All right? What do we have? Oh,
Easy one.
An easy one. Okay. It's the Earth. Yes, the Earth. There we go. Okay. Okay. This is? Thank you. Okay. What are we looking at? We got rings and we've got cloud tops in there, okay? A lot like Jupiter. Do we see giant storms like we see on Jupiter? Not so much, okay? All right, Saturn's going to go over here. Okay, what else we got? Okay, one more. This is our sun, okay? We looked at lots of pictures of the sun in multi-wavelengths yesterday. This is the sun in visible light. Again, this is the color of the sun as seen by the human eye with its sunspots. Okay, what are those sunspots? We talked about those yesterday. Places where what's happening in those sunspots? When we looked at the ultraviolet, what do say?
Flare?
Solar flares, solar storms. Actually, really more stormy stuff. These are magnetic storms in the sun. Okay, all right. You guys can have the sun here. All right, and the final one, which we don't need to do, is Earth. All right, this would be our comparison for weather. We've got lots of weather here on Earth. We don't need to. Oh, wait a minute. You guys don't have. You don't have one. Okay. Well, no, I'm just randomly doing things, so we're getting across. All right, so you guys can actually work with Earth on some of this stuff. Okay.
Okay.
I thought we had enough for all that. There's 2 over here, but there's 2 at most every table. What we were trying to do is give. All right. We're trying to do like works in groups of 2 or 3 together, okay? So if you don't have this table, you've only got 1 for 4 of you. You have 2 of them? Okay, great. I thought we had enough to work in groups of 2 or 3. If you need to, team up on something. All right. So if I may borrow this for a second. So that little warm-up there was to get you to recognize the objects and to take a look at the objects and what you can see with your eye. The idea is you're trying to tell us, imagine what the weather might be like on these objects, and especially in comparison to Earth, which you guys have Earth. If you don't want to do Earth, you can join another group in terms of doing that, okay? All right. So we would like you to make your best guesses. This is not graded. This is to make your best ideas of what you or think of what your students might think about the temperature on these objects. All right, where we've got cold, moderate, or hot. We've got atmosphere. All right, atmosphere, none, thin, or thick in terms of atmosphere. What do we think? Now, you can think of that in terms of physical size of the atmosphere, the physical layer of the atmosphere in terms of thin or thick, or in density of the atmosphere. All right, so think about that. Storms, none, weak, moderate, or strong. Okay. On the back side, we have seasons. Seasons, we want to think about how the variation, how strong winter would be versus summer, how hot versus how cold, how much change you would get over the year. Precipitation, all right, would there be precipitation on it? Because what we call it precipitation could be rain, could be other things, could be diamonds. And finally, greenhouse effect, another important aspect of it. What would be necessary for greenhouse effect? Atmosphere, also the presence of greenhouse gases. All right, do your worst or best or whatever. Yep.
On, you're going to hold on to that picture because you're going to share the information you have about your picture. So everybody participates. Sorry.
We ready to rock?
We are ready to go, Frank, whenever you
Okay.
are.
I'm just getting serious here. Okay, so let's see. Oh, there's still some conversation going on. I hate interrupting conversation because. No, it's a good conversation.
It was really about talking about the seasons and the
Fantastic. You wanna go first now since you caught my attention?
Sure.
Okay, guys. All right. I hate interrupting conversations because the reason we have you work in groups is because that's where science really happens, is in the conversation. The discussing of it, looking up answers and writing them down doesn't really get you into the idea. It's the conversations. We've heard a lot of conversations about seasons going on around here and what are the effects that would make for seasons. All right. Since they caught my attention first, they're going to talk about Saturn. Okay. All right. So first of all, we just go through the basics of Saturn. Temperature. What do you think of temperature on Saturn? All right. And what basis do you have to make any idea on it? Okay.
Cold because it's further away from the sun.
Okay. So cold because it's really far away from the sun. How much further? Do you happen to know? Okay, the truth is it's 10 times farther. Okay. Which is good. Okay. Saturn's orbit is what? 11 AU. Earth's orbit is 1 AU. Right. So that's about roughly 10 times farther away from the sun. So you could say that is cold, okay? All right, but when we think of cold and hot here on Earth, where do we measure the temperature? Huh? Yeah, where on Earth do we measure the temperature? On the surface of Earth, right? So do we measure the temperature of the clouds on Earth? Well, I'm sure some people do, but but they don't report that on the Weather Channel, do they? So that's another thing to think about in terms of temperature on a giant planet that's at a gaseous atmosphere. Where would you define that temperature? All right. You would have to define it at some depth into the atmosphere, right? You'd have to come up with something, all right? So does temperature, in one sense, temperature doesn't quite even make sense when you're talking about a gaseous planet, all right? But you can measure the temperature of the cloud tops, all right? Temperatures within the clouds by looking at the, what precipitates out, and you know what would precipitate out, they can figure it out, not me, because this is not my field. And it is actually very cold, okay? Just to confirm that idea. All right, what else? Atmosphere.
Thick.
Thick. Why?
Because before you said there were clouds.
Okay, lots of clouds, right? All right.
You can't see any, there's no land, so.
Okay, great. That's not asking for anything more than that, okay? They are called gas giant planets. The actual thickness of Saturn's atmosphere is about yay big on the radius of it, okay? It extends about a third of the way down from what I understand, okay? So that, I think we call that thick, yeah. I agree with that, all right? What about storms?
You said moderate.
They say moderate for storms, okay? You can't see many storms when you look at Saturn's atmosphere, right? But because there's clouds, there might be storms. Good reasoning. We like that. Okay? Over on the back, seasons.
Well, we said low variation.
Okay.
Because that's what we were just talking because seasons vary from the tilt to the sun, and it's further away, so we thought there'd be less variation.
Okay. So really important point. What are the really important question for seasons is, what does the seasons depend on? Okay? All right. And so you said the tilt of the planet relative to the sun. All right. So the seasons on Earth. Who's got Earth now? Where did Earth end up? Earth ended up over here. Okay? Could you pass me Earth for a second? All right. So the seasons on Earth are not because that it is closer to the sun or further away from the sun. All right? A huge misconception that kids will have is that summer occurs when Earth is closest to the sun and winter is when it's farthest from the sun. Okay? Something a misconception that has to be rooted out. Seasons occur because of the tilt of Earth, and that when the northern hemisphere is pointed towards the sun, we are in summer. When it's pointed away from the sun, we are in winter, right? So, in order to tell whether there would be strong seasons on Saturn, what would you need to know? The tilt of Saturn. I'm not sure I remember the tilt of Saturn. Do you? I don't know. All right. Somebody look it up on Wikipedia or on their iPad real quick. What is the tilt of Saturn? I do not believe it's very strong. Okay, but I believe it's about 13 degrees, because we do see the ring plane tilting up and down. What?
23 and a half. Oh, no, that's Earth.
Earth is 23 and a half. I recognize that number.
27. Yeah, you said so.
27. Oh, so I got it halfway right. Okay, so it's 27. All right, so it would be tilted over 27 degrees. I thought it was 13 degrees. All right, so it's got a larger tilt than Earth does. So if in terms of seasons, in terms of the temperature in the northern hemisphere at maximum tilt and at maximum tilt the other way. Just slightly larger than ours, okay? What do we consider our seasons? Would low variation or high variation in our seasons or moderate in between?
I guess if In the
Very
middle,
bad.
yeah, in the middle, there wouldn't be much variation at all, I'd say low. But then the further towards the poles would be a higher variation, so I guess it would be moderate in the middle.
Okay. So here's another point: is that what do we consider seasons on? Where would we put Earth? Since you guys just did Earth, where did you put Earth on seasons?
That's where we were struggling. We don't
Oh,
know.
cool.
Because I don't think there's much variation in our seasons.
All right. So the fact that it's going to be 90 degrees today and the fact that it could be, minus, 5 degrees in the winter, not much of a variation. Low variation, we'll call that.
Well, on other planets, isn't there like a lot more variation?
Bingo. All right. The idea is, if we have to have a standard of comparison here. All right. Always when you're talking through in a scientific term, if I say low variation versus high variation, what is your standard for low variation? Okay. So if we take Earth as low variation, it's got a 23.5 degree tilt. All right. Saturn has a 27 degree tilt. Do we consider that also low variation then? I'd buy that argument, wouldn't you? All right. Again, things to think about in terms of trying to think scientifically. What is your basis of comparison for these things? All right. I do not think there is correct answers to anything on this exercise, because the answers don't matter. It's the discussion of what you're basing your answer on. All right. Okay. Precipitation. What do you think?
We said yes.
You said yes
I
because
said yes.
Lots of clouds.
lots of clouds, so there could be precipitation. All right. You'd have to research that to really find out. I'd have to probably research it to see if I don't know of any precipitation on Saturn, but I'm not a Saturn specialist in atmosphere, so I would have to research whether there's precipitation. And finally, greenhouse effect.
We said no, because the greenhouse effect is from things that we are using, right, as humans? Aerosol can.
There is greenhouse effect that occurs naturally. It doesn't have to be human-induced. Okay? All right.
So then maybe,
Yes.
I thought the greenhouse effect was the presence of specific gases in the atmosphere that cushion and keep our heat in. The radiation from the sun comes in, but it can't go back out. Like
Right.
It goes around.
Mm-hmm.
So we contribute to it, but we have our own natural set of gases. And I thought it was specific
Yes.
to CO2, but I'm not sure if there are other gases that are specific to it.
Great question. Great question. CO2 is one of the greenhouse gases. Okay. Anybody know other ones? Methane. Okay. And actually, water vapor is one of the strongest greenhouse gases. All right. Water is a greenhouse gas. All right? Of course, we don't have much control over how much water is in the atmosphere. The oceans kind of control that. So humans can't do anything about that. But we can control somewhat our CO2 emission and methane by how many cows we put out on the range. Seriously, I hate to. It's not a joke that cow flatulence is a contributor to methane in the atmosphere. Okay. All right. So, but the other, I'm sorry, what? So, would there be do you think there might be greenhouse gases in the atmosphere?
yes, but you said it's holding in,
All right.
like,
You said no initially, and I said yes, because it's got a big atmosphere.
I love it when there's disagreement. Okay.
I let her go for it, because she had a good explanation, I didn't have.
Okay. No, these are great explanations. Okay. All right.
but the atmosphere is holding it into our surface, right?
There you go. That's the big point. Where's the surface here?
Yeah, there's no,
Can there be a greenhouse effect if you don't are trapping energy against a surface?
there's no surface. I mean, there's, well,
And also, if something's so cold that there's no, it's so far out there, like Pluto, like what is it trapping? Is there any heat there, even though there's methane gas?
Right.
Can
Okay.
there be a greenhouse effect?
All right, we'll discuss some greenhouse effect later on. But that you really, in this discussion is between the bunch of you, we've hit the nail on the head on this in terms of that there have to be the gases there, but also if it's going to trap energy, usually it's trapping energy against the surface. Okay, we'll discuss greenhouse in more detail during our discussion today. All right, fantastic. All right, so that was Saturn. What other one should we choose, John?
Oh, Venus is
Oh,
fun.
look, Ceres appeared. Okay, so go ahead. What?
Venus is fun.
Venus is fun. Well, since we are discussing greenhouse effect, let's talk Venus. Who's got Venus? You guys have Venus back here. Okay, so let's go through Venus. What did you think about, where do we start? Temperature. Hot. Damn hot. No, that's from Good Morning Vietnam, okay? All right, so anyways, what makes it so hot?
Proximity to the sun and majorly the greenhouse effect.
Proximity to the sun and greenhouse effect, okay? Not everyone's going to know that there is a greenhouse effect on this planet, but we'll get to there at the end. But first of all, proximity to the sun, it is 70%, excuse me. It is 70% of Earth's distance to the sun, right? But the energy from the sun goes as 1 over r squared, so it actually gets twice as much energy per unit area, because 0.7 squared is 0.49, 1 over 0.49 gives you 2, all right? So a factor of 2, that's just for the math teachers, trying to throw some math in for you guys, because I know this is a lot of science. So the 1 over r squared rule gives you that twice as much energy per unit area would help increase the temperature, right? All right, what else would help increase the temperature? All right, let's go to the next one. What's the next one? Atmosphere. We say thick, okay? Well, thick in what sense?
Well,
Sorry?
you can't see the surface.
You can't see the surface. Very good. That's. I mean, we're operating off of what you can see. All right, on this, you can't see the surface, so there's got to be a thick atmosphere, okay? It does have a thick atmosphere. The truth is that this atmosphere is thick in terms of density, but not really thick in terms of the thickness of the layer, okay? And this has come up in lots of previous discussions. And we recognize that we're ambiguous when we say thin and thick, and because this discussion is useful, we actually left it as being ambiguous, all right? Just so we could bring up this point. Because in Saturn, we talked about Saturn as having a thick atmosphere, well, possibly in density, but also in terms of actual physical thickness. All right? The thickness of Venus's atmosphere is about yay big. All right? It's about the same thickness in physical height as Earth's atmosphere. It's 1/60th of the thickness of the radius of the planet. All right? So that's an ambiguous point that we like to address. Go ahead. What's next?
You should clarify with thick like pudding.
Thick like pudding. Okay. All right. We have pudding clouds here. What flavor? Butterscotch? Who would really want to go to the tapioca planet? Come on.
Russians.
You said moderate storms?
Moderate storms, okay?
If there was an atmosphere that had to be.
If there's an atmosphere, there has to be some
I
storms.
always remembered some factoids that it rains sulfur.
Factoids about there being some rain, okay? All right. Again, this is when you take that's another great point, is that when you take all these factoids you might have in your head and then try and work it into a system, how much do they tell you on these things? You actually have to do a lot more research to see where that's going. All right, on the back side, we have seasons. What do we need to know about to answer the seasons question? We talked about it before. There's tilt. What is the tilt of Venus? Okay, that's good, and that's an important thing to recognize what you don't know. All right.
Went with low just because the thickness of the atmosphere, the temperature, the way that the greenhouse effect, kind of figured that would buffer
Okay.
any significant tilt that was there.
The greenhouse effect does an amazing job of buffering any seasonal effect. The greenhouse effect washes out the entire seasonal effect that's there. Actually, Venus rotates so slowly it can be considered to be totally upside down. All right. Its rotation period is longer than its orbit period. Okay. What is it? 287 days for the rotation, 278 days or 73 days for its orbit. So it can be considered to be rotating backwards just slightly, and to be upside down. Obviously, something slowed down Venus's orbit, Venus's rotation. Like Uranus, that's over on its side. We assume there was some giant impact that put Uranus on its side. For Venus, there probably had to be some impact that slowed down its rotation so much. Again, this is stuff that occurred billions of years ago. We don't have any good evidence for it, but this is based on theoretical arguments as to how that would have possibly happened. And finally, we got precipitation. You said you knew a factoid about what?
Rains, sulfuric acid.
Sulfuric acid rain. And yes, that is true. There is sulfuric acid rain, and it actually has been measured by the Venera probes passing through Venus's atmosphere. And finally, we talked about this already, but
Greenhouse effect is present.
greenhouse effect is present. Is it, what do we have? We just said yes and no. Okay, yes, it is definitely present. Actually, that's one of its defining characteristics of Venus is its greenhouse effect. Okay, it's what we call a runaway greenhouse effect. We'll talk about that some more. Where should we go from here, John? We've done a gas giant. We've done a rocky planet.
Let's do Mars.
Let's do Mars, okay? Mars over here. All right, folks at this table, or anybody else who did Mars as well, if we traded around amongst things. All right, start off with temperature.
Well,
Hot. Cold.
Same thing like the movie
Hot.
where when
Cold. Which one?
You're getting sunlight, it's hot. When it's not, it's cold.
When you're getting sunlight, it's hot, and when you're not getting sunlight, it's cold. Okay.
Yeah,
I don't think you can get more basic than that. So, what I need a little bit more than that. Sorry.
It's cold because the ice caps forming.
Because there's ice caps, it can be cold. Okay. All right. So what would contribute? All right. So we talked about distance from the sun with Venus. All right, making it hot. We talked about distance from the sun for Saturn, making it cold. Where's the distance of the sun for Mars?
1.33.
No, it's a little bit. It's so like Venus is 0.7, right? This is like 1.5 or 1.3 or 1.4 or something like that. 1.5. Okay. All right. So that would make it a little colder than Earth, just naturally, right? What other conditions made Venus hot? The atmosphere, the presence of the atmosphere. Okay. So let's skip to the atmosphere. What do we think about the atmosphere of Mars? She says she doesn't think it has much atmosphere, so you would call it thin, thick, thin, or none. Okay? What did you guys say? They said thin. All right. Anybody want to argue for a thick atmosphere?
No, didn't Arnold Schwarzenegger go to Mars and there's no atmosphere?
There you go. Total recall, right? No, this is great. I love it when we bring up movies, okay, because they set up an expectation. All right. So how many people saw the movie Total Recall with Schwarzenegger?
Okay, but
How many saw the crappy remake with Colin Farrell? I saw both of them. I definitely loved the Schwarzenegger one better. But yeah.
But even in the movie, it was inconsistent, because if it didn't have when they show it with no atmosphere, you can see that there's a sky that has a different color, so there had to be some kind of atmosphere there.
Yes, the movie did show there was some atmosphere, but not enough to breathe, because the ending scene, Arnold Schwarzenegger's eyes almost pop out of his head, right? Okay, and that was done with a rubber mask of Schwarzenegger's face. And anyways, so they a popular movie that says there's a thin atmosphere on Mars. Okay, well, that popular movie got it mostly correct. There is a thin atmosphere on Mars. All right, now the thickness of it in physical characteristic is kind of cool in that Earth, Venus, and Mars all have a scale height of about 100 kilometers. All right, so the thickness of it in its physical size is similar to the thickness of Earth and similar to the thickness of Venus, but the density is much, much lower. Okay, so factoid I remember that Mars's atmosphere is 1/100th the density of Earth's, and Venus's atmosphere is 100 times the density of Earth's. So there's factors 100 between Mars to Earth to Venus in terms of the density of the atmosphere. So that's that would be pretty thin in density. Okay? And also it would be relatively thin in physical thickness. Okay? What else we got?
Storms,
Storms.
we put moderate but dust.
Moderate but dust. There are dust storms on Mars. Did they have that in the movie? Dust storms? They had some sort of dust storm on Mars. Okay, I can't remember. But yes, there are some dust storms on Mars. We'll talk about those as well today. And whether you consider them moderate, severe, well, you can determine that after you see the talk. What else? Seasons.
We know it's still.
All right, so you don't know its tilt. All right, the other thing that could affect is of the shape of the orbit, right? All right. Most of the planets, Saturn, Venus, Earth, have relatively circular orbits. Mars has a slightly elliptical orbit. So Mars actually does get significantly a little bit closer and a little bit further away in its orbit. Okay, so the ellipticity of its orbit would play a little bit of a stronger role on Mars than it does on other planets. Okay, of course, it has a very thin atmosphere, so it's not going to be able to retain much of that heat even if it gets in closer or further away for the seasons. Mars does not have much of a tilt. It's got about a 20-something degree tilt. It's
25.
very much. What?
25.
25. See? All right, so that would be similar to Earth's tilt in terms of that. So the tilt aspect of it would be similar to Earth, but actually you can the variation in the distance would actually add to it for Mars. Okay? What else we got?
Precipitation. We didn't know what forms the ice caps, and if sublimation is one of the mechanisms that's considered.
Okay, you said a great word, sublimation. Has everybody how many of you have heard the word sublimation before? Okay, remember your chemistry classes. Going from solid to gaseous. Okay, that's sublimation without going through the liquid phase. That occurs on Mars. You're absolutely correct. These ice caps, they don't melt. They go from solid phase to gaseous phase. All right, and then they can precipitate out at the other pole. So while we talk about the condor on Earth migrating great distances from north to south, on Mars, the polar caps actually migrate from north to south via sublimation and precipitation. Cool. All right, and what about greenhouse effect?
We suspected there's some, but it was minimal because of the lack of density of the atmosphere.
Okay.
It's known to have methane gas.
All right. If you look up what the atmosphere of Mars is made out of, it's 95% carbon dioxide. So it has the greenhouse gases. It has the surface, right, as we talked about for those things. But it's got a very thin atmosphere, so the greenhouse effect can't be that huge. All right, it's 10 o'clock. It's time for us to take a break on this. We come back and we do weather.
We come back and we do. Wrong one. Come on. Your comparative planetology.
Comparative planetology. All right.
Something in the
So
works.
take a 15-minute